Now coming to the next question. In Classimet system, the yarn fault H2 as compared to the yarn fault C3 is thicker and longer, thicker and shorter, thinner and longer, thinner and shorter. So before answering these things, you have to know what are the yarn faults and which types of yarn faults are thicker, which are the smaller, which is the thinnest. So if we talk about Classimet faults, Classimet faults. In this, if you say that what are the thicker faults, so A4, B4, C4, D4. So A4, B4, C4, D4 are thicker faults, and also B3 and C3. B3 and C3 also comes in this category, thicker faults. And if we talk about A2, B2, A2, B2, H2, A2, B2, H2, these are thinner faults. So if we talk about this is typically this kind of thing. Here A4, B4, C4, D4, A4, B4, C4 and D4. So if we go down the line, then these are thicker faults, and as we go down the line, then the thickness decreases thereon. So the yarn fault H2 is comparatively the yarn fault H2 is comparatively thinner, but it is longer. So it is about 8.32 long thin fault. So the fault that is H, it's is said to be long thin fault as compared to the yarn fault C3. So yarn 3T is thicker, but it is shorter as compared to yarn fault H2. So which option would be the correct option? Yarn fault in this case, yarn fault H2 we are talking about this. So it is thinner, but it is longer. So option C is the correct option. Now coming to the next question. Determine the correctness or otherwise of the following assertion and reason. So in this case also one assertion and one reason is given, and you have to find the answer accordingly. Assertion is said it is from textile chemical processing part. It is a 2-mark question. Application of an optical brightening agent makes white fabrics appear brighter, and the reason is OBA, optical brightening agent, absorb energy in the visible region and radiate back in the UV region. So if you know about what is UBA, OBA, and what is the on which mechanism OBA works, then you can answer this question very easily. So what is OBA used for? OBA is a kind of nail that we use in uh, our homes for cleaning. So on typical principles these works. So OBA is just used to make fabrics appear more bright, so white fabrics appear brighter. So generally this is the right answer, ki the application of OBA makes the white fabrics appear brighter. This is correct. But what mechanism OBA works? It absorbs energy in the visible region and radiate to the UV region. So it says that, so it is the wrong answer. If you know about OBA system, then it absorbs in UV and radiate in visible region, 400 to 700 nanometers. So this is the visible range, and absorbs in the UV range region. So this is oppositely written in this case. It is said that OBA absorbs energy in the visible region, not in the visible region, but in the UV region and radiate back in the visible region. So this is wrong. So option A is true, but reason is false. So A is true and reason is false. So the correct option would be option number D. A is true, but R is false. I think you must have understood the concept and the mechanism behind the OBA working. Now, coming to the next question. This says that they determine the correctness or otherwise of the following assertion and reason. Assertion has said that nylon is dyed with acid dyes in acidic medium. Reason is nylon assumes a positive charge in the acidic medium and thus attracts the negatively charged acid dye molecules. So it is also a dyeing question from textile chemical processing. It is also a 2-mark question. So coming to the properties of acid dyes. So if you know about the acid dyes, these are anionic in nature, and these acid dyes are suitable for wool, silk, polyamide. Polyamide means nylon 66 fabrics, and modified acrylic. On what is the pH on which acid dyes are applied? So acid dyes are applied generally from a strongly acidic to a neutral pH bath. Because and one more thing about acid dyes is, because acid dyes do not have affinity for cellulose. Why? Because cellulose is degraded by the acid. In this case, if we use sulfuric acid or any kind of acid, then cellulose has no affinity for acid, and it's get easily dissolved or degraded in the acid bath. And these dyes combine with the fiber by hydrogen bond van der Waals forces through the ionic linkages that is there in the structure. So what is the mechanism? If we talk about these acid dyes, ASO3 Na, if we dissociate itself in the presence of water, then it comes out to be ASO3 minus plus Na positive. This is a colored anion. So nylon is dyed in, what the assertion is said in this type, nylon is dyed with acid dyes in acidic medium. It is right. Nylon assumes a positive charge in the acidic medium and thus attracts the negatively charged acid dye molecule. Nylon attracts the negatively charged dye molecules, and nylon assumes a positive charge in the acidic and it attracts the negatively charged dye molecule. So this is also the correct option that is said, and you can easily see from this equation that it is a dye molecule, and nylon, which is positively charged, is get attracted towards the negatively charged dye molecules. So both the assertion and reason are true, and R is the correct reason for assertion. I think it is clear to you. Now coming on to the next question. Determine the correctness or otherwise of the following assertion and reason. The assertion is says that the discharge printing of dyed polyester fabric is not possible and the discharging agent damaged the polyester fiber significantly. You have to answer this if the assertion and reason both are true, or if any one is true or both are false. So if you look at the discharge printing of polyester, so polyester fabric is dyed with dischargeable dispersed dye, and then it is printed with a paste that containing reducing agent for white discharge and non-dischargeable dyes for color discharge. So what it says, discharge printing for dyed polyester is not possible. So it is possible. It is possible because discharge printing is with the help of the reducing agent, dischargeable dispersed dye with the help of the reducing agent, and non-dischargeable dyes for in case of color discharge. So it is possible. The assertion is wrong. So if you notice, if assertion is wrong, then if you get by trick, if you know reason or not, then you can answer this question, because if assertion is wrong, then we are left with only the single option, that is option number C, because in option A, B and D, A are true. So you can answer this question if without knowing the reason or not. So the option C would be the right answer, but just read the reason for this. Discharging agents damage the polyester fibers significantly. It is the wrong. It is wrong, because discharging agents are used in case of polyester fibers for the dyeing and printing process, and with the because but in this case it is used with the help of the reducing agents. But if the fabric is dyed with HTHP method, then it is difficult to discharge the ground. But if the ground shade is obtained by carrier dyeing method, then it is easy to discharge the ground shade. And how this dyeing and process is done, if you have read, the cloth is first padded with a dispersion of dischargeable dye, and then it is dried at low temperature so that the color does not get fixed at this stage. And the bath that contains around 2 gram per liter of sodium alginate that is used as thickener, that make the entire paste acidic, along with the use of tartaric acid with a pH of around 5 to 6. And then the fabric is dried at around 60 degrees Celsius, and then it is printed with the paste. In this type, the entire dyeing and thereafter printing process is done. So the reason that is said that the discharging agents damage the polyester fiber significantly, it is completely wrong. Both the assertion and reason are wrong. So option C is the correct option. And we have answered this question as well. Now coming to another type of questions, that is NAT type of questions, numerical answer type questions. We will see these questions ahead. Now coming on to the next question.